All right, in this video I'm going to do an example of solving a differential equation. Actually I'll probably do a couple. These problems are from Delta Math, as you can probably tell. So this says, what is the particular solution to the differential equation dy dx equals 2x minus 5 over y squared? All right, so we write our differential equation and we use the process called separation of variables, in which we want to group the dy's with the y's and the dx's with the x terms, using valid algebra moves where you think of dy and dx as separable. They're just like variables. So the term you probably comes to mind is you can cross multiply here in a sense, right? It's not really a math operation, but it gets the job done. Y squared dy equals 2x minus 5 dx. Okay, and our goal is to solve for y. So I'm going to take the antiderivative, that's the notation we use, and then take the antiderivative of both sides with respect to their variables. The antiderivative of y squared is y cubed times a third. The antiderivative of 2x minus 5 with respect to x is x squared minus 5x. Now, when you take antiderivatives, you should be doing a plus c. You don't need to do it on both sides. Typically, it's with the side that has the x. Now, we're not done. We've got two things to do. We've got to solve for y, and we've got to figure out what the c is in order to find the particular solution. So that's where this comes in. They gave us a point. That's an initial condition. And so you can solve for c kind of in many instances in the process. I'm gonna plug in 4 for x and -3 for y to figure it out right now. Okay, so since I'm just gonna indicate we're using y of 4 equals -3, so that implies that 1/3 y is -3. -3 cubed equals x is 4. 4 squared minus 5 times 4 plus c. So this right side becomes, that's -27 over 3, which is -9, equals 16 minus 20, which is -4 plus c. So our c is, if I add 4 to both sides, -5. So I've got my c value. Now what? We're going to continue from here and just perform the algebra needed to isolate the y. So I'm at the stage where, 1/3 y cubed. 1/3 y cubed is equal to x squared minus 5x minus 5, because that was my c. I multiply both sides by 3 to get y cubed is equal to 3x squared minus 15x minus 15. And then I cube root. Y is the cube root of this thing. And there's my particular solution to that differential equation. Let's try one more. Okay, same thing, same process, different differential equation. So we know we got to separate variables here. So I'm going to go right to that. So I know that dy times e to the 3y minus 3, that must equal 2 sine of x dx. Okay, and again, in this case, you just think of cross multiplying. I take the antiderivative of both sides with respect to their variables. So the antiderivative of e to the 3y minus 3, well, e is its own derivative. So I'll copy that down. Now, if you take the derivative of what I just wrote down, it would be itself times a 3 because of the chain rule, but I don't see a 3, so there must be a 1/3 there. On the right side, the antiderivative of 2 sine of x is 2 times the antiderivative of sine of x, which is negative cosine. So -2 cosine of x, and we put the plus c here. All right, So we can use our initial condition to solve for for the c now. You could also you could wait on that if you want. For example, just to show you, you can multiply everything by 3, both sides by 3, and this becomes now e to the 3y minus 3. The right side multiplied by 3 gives you negative 6 cosine of x. Now you can write 3c. However, that c is going to be determined later when we plug in the initial condition. So, you can call it 3c, but you can still call it a c because it kind of absorbs that 3, and it'll work out no matter what, whether you call it 3c or just call it c when you plug in the initial condition. I know that seems strange, but it can absorb that multiplication of a 3 because it's a stand-in for a number that will be determined by the initial condition. So that is totally fine. Now, why don't we just wait to the very end to evaluate for c? Whenever you have a variable and an exponent like this, you need to think about logarithms or writing this in log form. So my base is e, which must mean that I need an ln relationship. Okay, so you can take the natural log of both sides or think about rewriting this in log form. I'm going to think of this as ln of negative 6 cosine x plus c, and I have a 3y. Okay, again, you can check that because e to the 3y minus 3 should equal this thing over here, and that's the statement above. Okay, and we are going to add 3 and divide by 3 so that I get 3y is equal to natural log of negative 6 cosine of x plus c plus a 3, and then we divide by 3. I'll call it a third. Natural log negative 6 cosine of x plus c plus 3. All right, well, we now still have to figure out what that c is. This is when we can plug in our initial condition. Okay, in the last example I did it early, now I'm doing it later. It's not really it doesn't really matter when you do it. Okay, so y of pi equals 1. So we use that fact. Y of pi is equal to 1 implies that when I plug in pi for x, I get out 1 for y. So that tells me 1 is equal to 1/3 natural log of negative 6 cosine of pi plus c plus 3. Okay, and now I have 1 equals a third natural log of, so cosine of pi is negative 1, so negative 1 times negative 6 is 6. 6 plus c plus 3. And now I can tell it was probably a bad decision to wait to solve for c to the very end, because I'm going to have to undo a lot of the things that I did over here, right? I think I should have solved for c early, all right? But it's worth seeing why that's the case. So you see now I got a minus 3. We're kind of undoing things that I did before. Just to get back to the c, multiplied by 3, you get negative 6 is equal to ln of 6 plus c. And now e to the negative 6th is equal to e to the negative 6 is equal to 6 plus c. So that c is equal to e to the negative 6 minus 6. So that was a kind of a lot of undoing what we did. So I think the lesson here is it's usually best to solve for c early, okay, if you can. In other words, we could have plugged in the initial condition right here, right? So I could have done it like right at this moment, get your c right away. In any case, my final particular solution would just be what I have here with a c substituted for what I just found. So I'm going to write it out and we'll be done. Y equals 1/3 natural log negative 6 cosine of x plus e to the negative 6 minus 6 plus 3. And there is my particular solution. All right, so that had some technique involved. This one a little more manageable, but there are two examples of solving differential equations.